right, welcome to lesson 5.7. We're going to be doing what's called completing the square. So far, we've solved quadratic equations by taking square roots, and that works when you can, when there is no linear term. We've solved by factoring, and that works when it's factorable. And then we've solved by graphing, and that works when it's the solutions are real and the graph crosses over the x-axis. But what if it's imaginary? We have no way to solve it up to this point. So this is the first method that would give you a solution if when you graphed it and it doesn't cross the x-axis at all. There are some equations that you can't solve even by graphing. So we need another method. The next two methods are going to be able to deal with that. So we're doing completing a square in this lesson and quadratic formula in the next lesson. There's also, so part of the objective here is, well, the first part is solving by completing a square. So that's the first thing we're going to do. The second part of the objective is rewriting functions by completing the square. So it's a skill that is kind of ancillary to the process of solving, where there's an extra benefit out of using this method, and it would involve, once we start looking at circles in pre-calculus and stuff like that, we're actually going to look at a quadratic function and how to rewrite it. But that's the last thing we're going to do. So, in lesson 5.5, we learned how to solve quadratic equations by applying square roots. So that's what we're going to do with this one. It just is going to look a little different. The first thing we're going to do is factor what's on the left side. And what's unique about what's on the left side here is that it is a perfect square trinomial, right? Because x squared is a perfect square, its square root is x. 9 is a perfect square, its square root is 3. You multiply them together and double it, you get 3x doubled is 6x, so it does match the middle term, so that's plus, and then you square that. So that's factored version of the left side there, 49 is 49. What you can do with this is take a square root of both sides. The square root of x plus 3 squared is x plus 3. You actually don't even need the parentheses anymore. That was just habit. And then on the right side, square root of 49, as we've talked about, when you're solving in an equation, plus or minus, square root of 49 is 7. So then you've got two different answers. You've got x plus 3 is equal to 7, and x plus 3 is equal to negative 7. Subtract 3, you get x equals 4. Subtract 3, you get x equals negative 10. So your two solutions are x equals 4 or negative 10. There you go. So let's try that again here. Again, this is a perfect square trinomial. X squared square root is x, 49 square root is 7. Multiply them together, double it, you do get 14x, so you use subtraction squared. So when you can factor it like that, then you take a square root of both sides. A little difference on this one, 75, not a perfect square, but it does have a square factor, which is 25. So that'll come out, the 3 will stay. So you end up with plus or minus 5 square root of 3. When I add 7 to both sides, I'm just going to leave it written like this, where x is equal to 7 plus or minus 5 square root 3. Just understand that means two different solutions, 7 plus 5 square root 3 and 7 minus 5 square root 3. So what about these two examples were unique to this working out really well? Well, it's that you're starting out with a perfect square trinomial on one of the sides of the equation. So that you're not going to get that hardly any time, because you could have anything over there. What this method is called is completing the square. So it's forcing whatever's on the left side to be a perfect square. So you can add or subtract a number to make that happen. So that's what this process is called. So if the quadratic expression is not a perfect square, you can force it to be a perfect square trinomial by completing the square. If given x squared plus bx, you add the term b divided by 2 squared to both sides, and then you can factor it as such. That looks more complicated than it really is, because let me just explain this. You just look at this number here, whatever the linear coefficient is, you take it and you divide it by 2. So I'm just going to take that number 2, divide it by 2, and I get 1. Then you square it, and you get 1. So that's what you add to both sides. And that's all we're doing in example 2, is just figuring out what is the number that completes the square. We're going to use this skill in example 3 in the whole process, but that's all we're practicing right here. So again, you just take that linear coefficient, divide it by 2, and you square it. So that's 36 for this one. 10, take 10, divide it by 2, you get 5. Square it, you get 25. So we're adding 25 to both sides to complete this square. These are all now perfect square trinomials. It's kind of a pain when the number is odd, because now when I divide that by 2, I'm going to leave it as an improper fraction. When I square it, I get 49/4. Notice how every time I'm adding a number, right? Because when you square anything, whether it's positive or negative, it becomes positive. So you're always going to be adding a number to complete the square. So here's just a regular old equation. We're going to solve it by completing the square. What I would do is just take whatever the constant is, move it to the other side. Right? Now you're going to take the 12. It doesn't matter that it's negative, because when I square it's going to be positive anyway. So I'm just going to write 12 divided by 2, and you get 6. And you square that and you get 36. So I'm going to add 36 to both sides. That step is what makes this called completing the square, because I just made that a perfect square trinomial now. It's x squared minus 12x plus 36 is equal to 31. This is now a perfect square. So I'm going to factor it that way. That's the whole point, to make it now look like example 1. So when I factor it, square root of x squared is x, square root of 36 is 6. Since that's subtraction, equal to 31. Now I'm going to take a square root of both sides, and I get x minus 6 is equal to plus or minus square root of 31. Unlike in example 1, where the radical needed to be simplified in some way, there's nothing else you can do with square root of 31. So I'm going to leave it. I'm going to add 6 to both sides, and you get x is equal to 6 plus or minus square root of 31. And I can leave my answer like that. This one here, same thing. I'm going to add, I'm sorry, there's nothing to send over like we had on the first part of the example here. So what I'm going to do is just complete the square based on the 6. So 6 divided by 2 is 3, squared is 9. So 9 is the number I'm going to add to both sides. So x squared plus 6x plus 9 equals negative 25. Now I'm going to take a square root of both sides, and I get x plus 3 squared is equal to plus or minus square root of negative 25 is going to be 5i. So this is a situation where it's imaginary. You could not, oh, I'm sorry, that shouldn't be squared there anymore. You cannot solve this by graphing. You cannot solve this by factoring. You cannot solve this by taking square roots. This is the way that we're completing the square is the only way you have to solve an equation like this now. Now I'm going to subtract 3 from both sides, and I get x is equal to negative 3 plus or minus 5i. Again, just understand that negative 3 plus 5i is one root, negative 3 minus 5i is the other root. This statement is 2 roots. We're going to skip that one. Don't worry about it. I'm not going to give you one like that. Point is, in completing the square, it can be a real pain when there's coefficient, when there's coefficient on the quadratic term, when the linear term's odd. So there is a better way to solve this one, and it's going to be when we do quadratic formula in the next lesson. The reason why we still are doing completing squares is because it is useful in other ways, and especially for those of you that will be in pre-calc next year. This is a worthwhile lesson for that reason. All right, second part of the objective was using completing the square to rewrite an equation. So completing the square can be used to rewrite quadratic expressions into vertex form. And this, like I said, this process will be used again in pre-calc when you're studying circles. So we did learn way earlier in the chapter how to take a standard form equation and rewrite it as a in vertex form, using the opposite view of 2a to get the x-coordinate of the vertex, and then you substitute back in, you get the y-coordinate of the vertex, and then put it all together. What you can do here is figure out what would complete the square. All right, so still based off of that 10, half of 10 is 5, squared is 25. All right, so what you need to do is turn the constant plus 25, right? But essentially what you need to do is figure out what is this other number going to be then. We'll call it x. So essentially what you have is 25 plus x has to equal that -2. You can set up a simple linear equation and solve for that. So you subtract 25 and you get x is equal to -27. So the idea is that these two numbers need to add back to what you started with. 25 plus -27 is -2. And then I need the 25 because that's going to complete the square with this part here. Okay. So now when I factor x squared minus 10x plus 25, I get x minus 5 squared. And then that minus 27 is on the outside. And this is the vertex form of the equation that was in standard form to begin with. All right. And it's kind of the same deal. We're going to skip this one. So I will give you a couple questions that are similar to these in as an exit ticket. And you can try those, have both the notes and the exit ticket done by class tomorrow. And we will go over the exit ticket and you can start the practice. All right, so let me know if you have any questions.